Hi everyone! Today we're going to be sharing with you our tech talk in which we discuss how we created our animated bar chart racer for CodeLabs 2020. My name is Lena Shahoob.
My name is Kirsten Graham.
And I'm Anusha Puri.
So let's start with the problem. Our goal for this project was to answer the following question. How do we visualize data that 1. Needs to maintain sorted order, and 2. Changes over time, in a way that is visually appealing and easy to understand?
So, to solve this issue, we created an animated bar chart racer. And basically what this is a series of graphs from specific intervals, so that when you combine these graphs together, you get an animated chart that helps visualize changes in data over time. And it creates an effect in which the bars race to the top of the chart based off their rank and their amount, and it plots the category, which is the y-axis, versus the amount, which is the x-axis. It's been very popular in recent years on YouTube and other social media sites because it has the ability to present data in a way that is very concise and engaging. It can be used to visualize nearly any data set, so it has a variety of uses, and you'll see some of those examples. So this is just a baseline generic example of what our graph looks like. As you can see, we have the category on the y-axis, and on the x-axis we have the amount. This is before using any of the customizations we've built into our GUI. Now, this is an example when you actually take a real-life data set, and this shows COVID-19 cases by country, and you can see that the value of what country's on top changes based off its numerical amount, which creates that racing effect.
Now let's go over the flow and organization of our program. On running the program, the user is presented with an interface that allows them to specify how to create the bar chart racer animation. They can choose their data, which includes their target file location and how its time column is formatted, choose the formatting and frame count of the animation, and finally, plot the animation. Once the user hits plot, their selections are passed to a function that handles running the animation. It first calls the processing function, where the program reads in the data from the selected file, then scales the number of rows in the data to create a smooth animation and match the selected frame count. Once the data is processed, it is passed to the animation function, which calls a graphing function to plot a single sorted bar chart for each time interval in the data. This displays the completed bar chart racer, which is now available to save from the user interface.
In terms of the modules we imported, we first imported Pandas, a data analysis library to read in and process data from our CSV files. We then imported Matplotlib, which is a plotting library that we use to plot the components of our graph, animate the frames, and export the animation. And lastly, we imported tkinter, a user interface package to create the interface portion of our program.
So now we're going to move into the user interface part of our code. So the user interface, as Anusha mentioned, was created using tkinter. And the goal of moving from just baseline Matplotlib code to creating a GUI was to allow for user customization and ease of use. And you can see a screenshot, but basically we had 6 core areas. We had an upload button for the CSV. We had a place to customize the chart and axis labels. We had date formatting options. We had a slider for the number of frames and the number of bars. We had a color chooser. And lastly, we have a save and plot graph button. First things first, we have the upload button. And you can see the code that created the upload button on the left. The top part actually created a default name for the CSV file, and then it stored that file name as a string variable. And then we went on to create the actual select CSV button, and we also created a button for the user to reset their selection in the case that they didn't like the CSV that they put in on the first time. Next, we had our chart title and axis labels. So the first step was to create entry widgets for each title label, and we set a default entry like animated bar chart racer or amount or categories. And then after that, we created a show button and a get method, which would allow the program to access these actual user inputs. Next, we moved on to date formatting, and the first thing we did was create a checkbox to ask the user whether their index column is formatted as a date. And so you can see that was done through a Boolean variable. Then we created the actual window for the user to input the format that their date is in. And lastly, we created a pop-up using date info that appears when hovering over this previous date format window. Next, we moved on to creating the slider for the number of frames and bars. First, at the top, this was for the slider for the number of frames. We created the label, then we created an actual horizontal scale and set the limits from 1 to 1000. We followed the similar process with creating the number of bars, and the only difference was that the slider goes from 1 to 20. Then we had the color chooser, and this was one of the most exciting parts of creating the GUI. So we used a Boolean variable once again to create a checkbox to see if the user wanted a custom color or if they wanted to stick with the default color. Then we actually created the color chooser itself, and basically that code there will open up a window, and then the user will be able to choose the red, green, and blue color values they want, and it'll store the resulting color they select as a hex code and then as a string variable. And this is an example of the actual color chooser. Lastly, we had our save and plot graph button. So the save button was the code on top, and it just created a basic, button to save the CSV file as a animated graph stored in a GIF file, and then it would format this button on the grid. For the graph button, it built a button that created the animated graph when clicked, and it uses the get method to take into account the user's selections for things like the titles.
In the data processing function, we read in the selected CSV file as a data frame, which is a tabular data structure used in Pandas. If applicable, we also parse the index column as a date and convert it to an integer for simpler processing. Then we rescale the data in two ways. First, we add a row for each interval of time. If the data given has irregular intervals, going from 2011 to 2012 to 2015, for example, this step ensures that the speed of animation will accurately represent the rate of change in the data. Next, we expand or condense the rows of the data frame to match the chosen number of frames. The expand function inserts new rows between current rows as needed, and the condense function selects rows at an interval that will give approximately the correct number of frames. Let's look at an example. Our original data frame, read in from a CSV file, has rows that progress from 2014 to 2050 at irregular intervals. We add a row for each year and use linear interpolation to fill in the new rows, which are indicated by the boxes in this image. Then we rescale the data to match the frame count. In this case, we need to condense our data frame to 10 rows. So, based on the current number of rows, we need to select every fourth row. This creates our final data frame, which is now ready to be graphed.
To animate our graph, we use an animation function, which had two main components: the drawing graph function, which contains information on the formatting specifications of the graph, such as the axes values and labels, along with the ability to adjust the number of bars displayed on the frame. The second component of the animation function allows the user to customize the color theme of the graph, or randomly generates colors for the bars. The animate function first takes in a variety of parameters, including the chart title, axes labels, the number of bars displayed, and a hex code if the user chooses to pick a custom color. We then set the horizontal and vertical constraints of the graph axes using the maximum and minimum values of the data. This ensured that the graph fit consistently on the frame and was scalable based on the given data. Next is the draw graph function, which establishes the necessary x and y values of the graph and plots the data. In the first column, the data frame is split into individual frames, where each row represents an individual frame at a certain point in time. The values within each row were then ranked to determine the order of the bars on the graph. Through the bar slider on the interface portion of the program, the user is able to select how many bars are displayed on the graph, for example, the top 3 values at any given time. In the second column, a nested for loop is used to find and add the top n values to a new list of updated values. These values are then used to assign the appropriate categories, or y values, and colors to each bar. The last component of the animate function allows the user to adjust the colors of the bars. We offer two options. First, to pick a custom color for all the bars through a custom color chooser on the user interface, or to randomly generate colors for the bars if a custom color was not chosen. We then plotted each frame and compiled the images through the func animation function, thus creating the animation. We definitely learned a lot during this project. It helped us learn more about coding in Python, the software development process, and working as a team. We learned the basics of manipulating and visualizing data in Python with the help of specific modules. We also learned how to coordinate development on a team, and how to use Git and GitHub for version control, and organize our tasks with an Agile board on Trello. Another skill we developed as a team was managing remote work, which requires a lot of good communication and coordination.
And there's still more to do. In the future, we could improve the visualization by giving the user more options for customization, such as choosing their font, a color theme, or the orientation, horizontal or vertical, of their graph. To add more information to the visualization, we could display the time, for example, the year corresponding to the currently displayed data, on each frame of the animation. Our current program displays the animation in a separate window, and multiple animation windows can be opened at the same time. In a future version, the animation window could be embedded in the window with the interface. This would mean fewer windows for the user to manage and a better experience. Finally, to make the program easier for users to set up and access, we could either package the program as an executable or create a web version of our program.